Now, the same instructions for the last problem are holding true for this next problem. We want to sketch the region enclosed by the following equations, decide whether to integrate with respect to x or y, and then go from there. Okay, so the region is obviously right here. And we've got a little bit more work to do on this problem because we need to know what values for which that region holds, or excuse me, for which those two curves intersect, which will hold in that region. Now, I grant you that I've already done this in Desmos. So I've already graphed these two curves. They're right there. And so if I want to know the points of intersection, I can just click on the points of intersection and find that it's -3, 3, and 0, 0. Okay, so I know that the values are 3 and 0. They're sort of given in the graph, but that implies that we have a graph to begin with. So if we don't have a graph to begin with, we could have to find those values by hand. Okay, so if we wanted to, so if we want to find the intersections by hand, we don't have to because it didn't ask us to. So we could just use Desmos. But if we want to find them by hand, you would want to set the two equations equal to each other. And we, of course, have two curves. We have kind of this blue one right here. And then we have this green one right here. Now, which one's which? Well, we have Desmos available to us, I mean, if nothing else. But we can kind of tell which one's which if we really struggle for it. The green one right here is the y squared minus 4y. And then the blue one is 2y minus y squared. Right? I mean, if you don't believe me, you're welcome to check me in Desmos. Sure enough, that's the one that's the 2y minus y squared, the blue one. And then the other one is the green one. Cool. Okay, so there they are in all their glory. So this is k of y, and then this one was h of y. All right. Okay, so if we wanted to find the two intersections by hand, we would want to let h of y equal k of y. So it'd be 2y minus y squared is equal to y squared minus 4y. And we would solve those two, or set them equal to each other and solve. So that'd be, bring the y squared over, it's 2y squared plus, minus 6y equals 0. Factor out a 2y. Lo and behold, y equals 0 or y equals 3. But it's also verified in Desmos. I mean, Desmos tells us the y values for the points of intersection. So it's the 3 and the 0 that we care about. Lovely. All right, so we're rather obviously going to integrate with respect to y on this particular problem because I have functions that are in y. Why bother messing that up, right? Okay, so I'm going to have a curve here. It doesn't really matter where I draw my rectangle. I'll draw it up here. There's my rectangle. Yes, you do have to draw them. You have a thickness or width. That's dy. Yes, you have to write that. And then a length that is, let me write it this way. This length right here is right minus left. So that would be k of y, the right curve, the blue one, minus h of y, the green one. That's the hardest part. You got to figure that out, right? So right minus left. Now that we have that, we can go find the area. So we know that we're integrating with respect to y, by the way. We kind of already figured that out. I mean, look at those two functions. The trick is that sometimes you'll have to switch them up, but not in this case. So over here, we've drawn our graph and all that good stuff. And then technically step 1 is shading in yellow, but I don't feel the need to number that. All right, so the area would be the integral from, let's see here. our lower number, which is 0, to our upper number, which is 3. And then we would take the right curve, which is k of y. This is the right curve. Minus the left curve, which is h of y, dy. Because, whoop, my pen got in there. Okay, so this is the integral from 0 to 3. K of y was 2y minus y squared, minus h of y is y squared minus 4y dy. All right, so this is the integral from 0 to 3, 2y minus y squared minus y squared plus 4y dy, which is 6y. Oh, I guess I'll just put it here. 6y minus 2y squared dy. That would be 6 halves y squared minus 2 y cubed, because we add 1 to the power and then divide by that new power or multiply by its reciprocal, from 0 to 3. Oh, I guess I can just make that into a 3, because 6 over 2, we all get it. It's 3. Oops, sorry, I smeared. There we go. So 3y squared, and so that would be 3 times 3 squared minus 2/3 times 3 cubed minus a big fat 0. So we don't have to worry about the back half, because 0 going in there and 0 going in there is all 0. So that's 27 minus 2 times 9, which is 27 minus 18. So this is 9. Now, if you don't believe me, because I did do that math in my head, you can't trust me. There we have it. So there's our lovely rectangles. Zoom on and off, slowly but surely. And we want to see the integral calculation. In fact, I am correct, and it is 9.